Congratulations on completing the course. You have gone from beginner to expert in the Python programming language, and you should be proud of your achievement. This course was packed with hands-on projects and coding exercises to ensure that you got practical exposure working with the concepts you learned. Let's go through a quick rundown of what we learned in this course as a recap. First, we learned about the fundamental topics in computer science. The purpose of this section was meant to provide some context for what computer programming is, and to introduce newcomers that may have never programmed before to the topic. Then we set up and installed PyCharm, an industry standard Python code editor, onto our machine. I walked you through the process step by step. We also learned where the Python documentation is and how to refer to it when coding. Next, we got started working with basic Python code. We wrote a Hello World program, got started working with variables, conditional statements, and loops, and got a handle on some of the other major programming constructs that the language has to offer. Then we took a deep dive into types, data structures, and collections. We learned about the basic types like string, integer, float, and bool. Then we went over some of the core collections like lists, tuples, dictionaries, and sets. After that came a whole section working with strings in Python. We learned all about indexing and slicing, the different methods that strings support, string concatenation, and escape sequences. Then came a hands-on coding exercise where you got hands-on practice working with strings in Python. Next, we learned about Python's math module. We learned about the different constants and functions that the library contains. Then we did a coding exercise to solidify the knowledge that we learned. Then came a section on working with date and time data in Python. We learned about classes like datetime, date, time, and other classes that Python supports for working with date and time data. These skills will come in handy anytime we are building apps that have aspects that rely on real-world time. After that, we took a deeper look at control flow statements and loops. We gained an understanding of programming constructs like if, elif, and else, for loops and while loops, and more. Then came some coding exercises to test our ability using the if statement, for loop, and while loop. Next came a section on file input and output. We gained an understanding of how to obtain user input in Python. Then we learned about how to open and close and read and write to files. Working with files is an important task that all Python developers should understand how to do. Next, we learned about functions, blocks of code that can be reused throughout our program. We learned how to create a function, call a function, and then learned all about parameters and arguments. At the end of this section, we got a look at one of the advanced aspects of function programming, recursion. After that came a look at regex, or regular expressions. Regular expressions can be tricky, but they are great for programming find and replace logic in our code, and for working with strings and pattern matching. Python gives us tools like regular expression objects and match objects, built directly into the language to work with regex. Then we learned how to parse XML using Python. This section gave us a solid understanding of XML and the different ways we could use Python to work with XML. Next, we learned about parsing JSON with Python. We learned what JSON is and the syntax for working with JSON, aka JavaScript Object Notation. Then we learned how to go from JSON to Python and from Python to JSON. After that, we learned about character encodings. We looked at what a character encoding is and then took a look at Unicode. Next came a section on Object-Oriented Programming, or OOP. We learned what Object-Oriented Programming is and the 4 pillars of Object-Oriented Programming. Then came a section on trees. We learned what the tree data structure is in computer programming, and then took a look at some of the basics of trees. We also learned about traversing trees, and also got a look at implementing breadth-first and depth-first searches on trees in Python. Then came some coding exercises on traversing trees. After that, we learned about the graph data structure in computer science. We got a look at what a graph is and the basics of working with graphs. Then we learned how to implement a graph in Python as an adjacency matrix and an adjacency list. We learned about depth-first and breadth-first searching in Python. Then came a section on linked lists in Python. We learned things like what a linked list is, how to create a linked list, and how to traverse a linked list in Python. Then we learned how to insert nodes into and remove nodes from a linked list. After that, we learned about debugging and testing Python code. We got an understanding of what debugging is and the different types of errors in computer science. We went over the main types of errors we could come across when programming in Python. Then came some hands-on coding exercises to build up your debugging skills. Next, we learned about PEP, the Python Enhancement Proposal Standards. We learned about what PEP is and some of the different coding standards there are for coding in Python. After that, we learned about documenting our code. We learned why documenting code is important. Then we got to look at the difference between commenting and documenting code. We also learned about docstrings and documentation tools. Then we learned about refactoring. We looked at what refactoring is and some tools that PyCharm gives us for refactoring our code. Then came a coding exercise on refactoring Python code. Next, we learned about code reflection and introspection in Python. We learned what reflection is and some functions that Python gives us to work with reflection. After that, we learned about bitwise operations in Python. We learned what bits are and what bit shifting is. We also learned how to do some bitwise math by hand. Then we learned about the different bitwise operators for left shift, right shift, and, or, complement, and exclusive OR, aka XOR. Then came a section on using Python to automate tasks. We learned all kinds of neat ways that Python could be used to automate everyday tasks and make anyone's life easier that uses a computer. This section was a great look at the versatility of the Python programming language. After that, we learned about socket programming and multithreading, two of the more advanced computer science topics. Next, we learned about asynchronous programming in Python using the Asyncio library. We learned what asynchronous code is, and then learned how to write asynchronous code using coroutines and tasks. Then we learned about shell scripting using Python. We got an understanding of how to open the shell, execute commands, and execute a Python script. After that came a section on cybersecurity programming and ethical hacking using Python. We took a look at some common cybersecurity coding methodologies. If you want to become a cybersecurity professional, I cannot stress enough the importance of Python, given how popular it is in the field. Then we learned about using Python version 2 to maintain legacy systems. We configured PyCharm to work with Python 2, and then learned about key differences between Python versions 2 and 3. After that came a section on using Selenium WebDriver with Python. We downloaded and installed the Selenium WebDriver program, and then learned about the program basics and navigation, before we dived headfirst into the program. Next came a section on using Kivy to create mobile apps using Python. We downloaded and installed Kivy onto our computers, and then built a mobile app using it. Next came a section on using Python for data science programming. We learned about two main libraries used for data science programming, NumPy and Matplotlib. We gained an understanding of how to plot graphs using Python code. Next, we learned about machine learning and got experience writing the four main types of machine learning programs: regression, classification, clustering, and recommender systems. Then came a section on cryptography. We learned how to encrypt and decrypt files, and also the different types of ciphers used in cryptography. We got exposure to implementing ciphers in Python, and an overall understanding of the field of cryptography. After that, we learned about speech recognition. We gained an understanding of the recognizer class, and how to work with audio and microphones for creating speech recognition programs. We also built a hands-on project that allows Python to interact with us based on the words that we say. Then we learned about IronPython, which is a combination of Python and C#, or really Python and the .NET framework. Next, we learned about Jython, which is a combination of Python and Java. We gained an understanding of the syntax of Jython, and how to work with object-oriented programming and GUI applications using Jython. After that, we learned about using Python to work with images. We took a look at libraries like the Python Imaging Library, OpenCV, NumPy, and SciPy for working with images in Python. We also learned how to use Python code to build a Sobel image filter. Then we learned about building Python GUIs with tkinter. We learned what a GUI, or graphical user interface, is, as well as what tkinter is. Then we learned what a widget is, and got an understanding of the different widgets that it supports. After that, we learned about building a GUI using tkinter, and then got hands-on exposure building a calculator app with tkinter. Next, we learned about computer graphics programming using Python. We learned about the Turtle Graphics API, a fun and beginner-friendly Python library for working with turtle graphics. The next three sections taught you how to use these skills to build 2D video games. We built a Galaga space shooter video game, a Batman action video game, and a Super Mario video game. I walked you step by step through how to build these video games from the ground up and incorporate the graphics for them into the game. As a professional game developer, these were some of the coolest sections for me to work on and record. Then we learned about the Pygame game engine and got hands-on experience using it to build a 2D racing game. Then came a section on 3D game development using Panda 3D. We installed Panda 3D and learned about navigating the program. Then we went over each of the major features of the Panda 3D game engine. After that, we learned how to use Python for technical art in the Blender 3D modeling program. We got an understanding of how to use Python to automate tasks and interact with this industry-standard 3D software. Next, we learned about design patterns. First, we looked at what design patterns are, and then we learned about all 23 Gang of 4 design patterns and how to implement them in Python. Design patterns are important for all programmers to know, especially if you are looking to work professionally. Then we learned about each of the major searching and sorting algorithms in computer science and how to implement them using Python code. Finally came a section on practicing Python programming through interactive quizzes. This helped us solidify the knowledge that we learned in this course. Great job! You have mastered the Python programming language. The skills taught in this course are highly in demand in the tech industry, so now that you have a solid understanding of Python programming and a portfolio of projects, you may be well on your way to landing an entry-level developer job. Thanks for taking the course and feel free to reach out to me with any questions you may have. Best of luck for your future.